Good morning. This presentation is about the paper An Approach for Standardization of Semantic Models for Building Renovation Processes. The paper has been developed in the context of the BIM4EEB project, that is an H2020 funded project. The BIM4EEB project aims to develop a BIM-based toolset to support designers, construction companies and service companies in providing attractive solutions for building retrofitting. In the context of the entire project, in this paper we focused on a specific area that is the one about semantic and instance-based interoperability. This area is of critical importance to support the communication and collaboration between the different subjects and the different tools that can be considered in renovation processes. To do so, we analyze semantic web technologies, linked data, and ontology, and we analyze a way to harmonize what already exists and what can be developed according to the specific need of renovation processes in construction sector. Another point is that we studied a framework of standards that we can found in relation with interoperability area, and we provided inputs and analysis that can support the improvement of the existing standard and the development of new one. If you look at the context where the research has been developed, we are looking at renovation process in construction sector, focusing on what is digital innovation about these points. When we talk about digital innovation in construction sector, we usually refer to building information modeling. And when we talk about interoperability in this context, we usually refer to the IFC schema. The IFC is an open and neutral format that can be used to support the communication between different tools and different subjects in construction processes. However, IFC still has some limitation. For example, the interoperable process based on the IFC format is still a file-based exchange process. That means that we have limited instance-level interoperability. Another point is that there is a difficulty in creating a bidirectional interoperable process. That means that it is difficult to create data flow that comes on the two ways from the place where the models, the information models are developed, that are developed in native format, and the one where the information models are exchanged, that is the IFC format. For this reason, in the research field can be found several works that tries to overcome this limitation, analyzing the use of ontologies, semantic web, and linked data technologies. In this case, instance-based interoperability is allowed. It can be created a link or more links about multiple domains and can be defined logical inference and proofs based on this data. So in this work, we analyzed what had been already developed in the context of ontologies and semantic web in the construction sector. So we analyzed the IFC OVL ontology, for example. This is an ontology that translates the IFC data schema in an ontology, the building topology ontology, the ontology for property management, and on the other hand, we analyzed the existing framework of standards, that is, for example, the one where we can find the data structure of IFC, but also the one, for example, related to the semantic level of the IFC, that is the IFC dictionary, to understand if there are issues or possible incoherence between the different standards. In what way we analyze this point? So looking at the entire picture with reference to the BIM4EEB project, so we started from what are the inputs that comes from other work packages of the project. So we have a base of information requirements and use case requirements that can be used to focus the attention according to the needs of renovation processes in construction sector. So we analyzed the existing ontologies like the one that we listed before, and we identified possible gaps according to the needs that we identified in this specific context. For this reason, we developed new ontologies following a modular ontology perspective. That means that instead of developing one big and massive ontology, we developed several small ontologies that can be coordinated one to each other to allow a dynamic analysis and work on the different data and different framework. From these, we provided a way to harmonize the different ontologies of the new one and the existing one, and to evaluate with evaluation methods, criteria, aspects, what we developed at the end. The analysis for the development of new ontology and for the analysis of the existing one, so for the evaluation of what is missing, have been based according to different points. So on the one hand, according to the different components that we can have in one building. So we are talking about existing building and renovation process. So we have to understand what are the information that we have to include in building elements, for example. We have to understand the different perspective of the different subjects, of the tenants, the operators, the owners, and understand, for example, what are the information required to evaluate the performance of the building. All these points have to be analyzed according to the entire life cycle of the building and allowing a dynamic analysis, a dynamic intervention with the data during the life cycle of the building. On the other side, we divided and found different areas that can be identified in the context and can be considered as critical for renovation processes. So you can find here listed the areas that can be analyzed to understand all the information that we're missing and all the information that we need to develop and to consider. So from this analysis, we identified all the gaps and we were able to develop the new ontologies that we identified as critical. You can find here on the left an image that represents on the bottom all the new ontologies that have been developed in the context of the project, and on the top of this image the existing ontology, and so the relation between the new ontologies and the existing one, so that we can find an harmonization between the different ontologies and a coordination between the new ontologies, the existing ontology, and what are the renovation activities that have been covered in the BIM4EEB project, so in the context of the renovation intervention for construction sector. To recap what we have done and what are the impact of this work according to the results that we found. So we started from the analysis and comparison of existing standard and existing ontologies. We analyzed the standard and ontologies in the specific context of application that are the context of renovation works in construction sector. From this analysis, we obtained a report about missing areas, issue and incoherence about standards, and what are also the needs and the missing points on the existing ontologies. So this report is a report that summarize what are the possible improvement in the existing standard and the possible future development for standards, and on the bottom what are the new ontologies is exactly the framework that we described before, so the framework of the new ontology developed in the context of the BIM4EEB project and their relation with the existing one. For those interested in looking at all the ontologies that have been developed, you can find here the link where all the ontologies have been published. And last note is that the report that we identified and developed in this context have been moved to the standardization bodies to support what is the improvement of the existing standard and to provide inputs for the development of new one. So I hope that you enjoyed the presentation. Thank you very much.